You are listening to the HYDAC podcast. In each episode, we share our knowledge with you in topics related to hydraulics and automation and control, from the basics to the current trends. Stay tuned. Welcome to this episode of HYDAC podcast. I'm your host, William Shaw, and on this episode, we'll be discussing part 2 of digital transformation, which is Industry 4.0 in the fluid power industry. Here in our studio to discuss this topic with us, I have Mr. Paul Marley. Paul has been involved in the fluid power industry for over 30 years, both as a hydraulic fitter and technical trainer, a role that he currently holds as HYDAC's technical training manager. Welcome, Paul, and thank you for coming into the studio today.
Well, it's a pleasure to be here.
Last podcast, we discussed what is Industry 4.0 and some of the enablers of Industry 4.0. Would you be able to give us a brief summary of what that is?
Okay, so for a very brief overview, the enablers of Industry 4.0 are essentially a group of diverse technologies that all work together in an ecosystem. And those technologies are as diverse as machine learning, robots, additive manufacturing, and cloud technology. But if you'd like more information on that, of course, go back and listen to episode 1 in this series.
It sounds like these would supplement the fluid power industry more broadly and not impact directly. So how does Industry 4.0 impact the fluid power industry?
Well, it's a fair question, and it depends on which enabling technology you're looking at, because some of them are going to be more relevant to us than others. There's no question there. When it comes to, for example, cloud technology, we use it, we don't make it. When it comes to robots, we use them in our manufacturing, but we're not producing robots. So then, which of these technologies is going to be more interesting to us? Well, from our perspective, there's only really a combination of these technologies that, when working together, that are going to be working as a solution for Industry 4.0, and ultimately that's what 4.0 is all about. But of those enablers, those segments, the one that is the most interesting to us and where we have the most impact that is directly affecting our business, that's the field of predictive maintenance.
So what is predictive maintenance? How is this different to regular maintenance that might be undertaken?
Yes, thanks. So that's a pretty fair question and one that I can answer very broadly. So there's different types of maintenance. The first is, of course, reactive maintenance, and that's you're going to be repairing breakdowns when they occur. Beyond that, of course, you doing things to intervene with the machine before those breakdowns occur, and that's called preventative maintenance. So preventative maintenance is that you're basically doing things on an hourly basis, on machine hours or on calendar days, or even on kilometres if it's a road-going vehicle. So at certain intervals, you're going to be doing certain things to keep your machine running, whether that be mobile or stationary equipment.
So how do you know when to undertake the predictive maintenance if it's not at a set time or an interval?
Well, the answer to that question is really the definition of what predictive maintenance is. With the preventative maintenance, what you're doing is, as I said, doing this on a certain set time. So you've got what's called PMs, and that's a task that you'll go and do on a certain date, and you'll be tasked with that work. With predictive maintenance, you're only going to be doing the work once you see a reason to do it. So you're really only looking at the condition of the machine to ascertain when to intervene, rather than do it just because it's that time of year.
So how do you make an assessment on when to intervene? What kind of things are you looking for, or what kind of information you're drawing upon?
Well, the only way that we can make those assessments is to actually do it with some sort of technology, with some sort of clear method of being able to get it right. So what those technologies are is essentially you've got sensors on the machine and you're looking at the condition of the machine. So traditionally this has been called condition monitoring. In the context of Industry 4, it changes its name. So predictive maintenance is now that we are predicting a future state for the machine. And how that works in a nutshell is that you're collecting data on the machine. And historically, you can go back to that data and you can refer to that and look at how things have happened in the past. And what you're also doing is looking at the current state of the machine. So knowing the current state of the machine and knowing how it's behaved in the past, you then apply the past from the present going forward, and then you can predict a future state. So time travel.
So as you just described, condition monitoring has been around for a fair while, and it's now being considered as part of Industry 4.0. What has changed to enable that change to become part of Industry 4.0?
Yeah, from the outset, it just simply sounds like a change of terms and therefore not very interesting to us. But it's a lot more than that. Predictive maintenance is very different to condition monitoring. Condition monitoring, basically, you're looking at the current state of the machine. You're taking readings on what it is now. Predictive maintenance is a level above that, essentially. It takes a technology of accurate forecasting and so on. So what has changed is what we're actually doing with that information. So traditionally, we would be recording the state of the machine. And what's happening now with the Industry 4.0 is that you're collecting data on that machine. But the difference is that data is being collected more passively. It's happening all the time and it's happening in real time. And the fact that then you're recording information in real time means that your periods between when you're taking the readings are much less than they are normally with condition monitoring. So what that enables you to do is assess with greater accuracy the current state of the machine, and you can pinpoint a form of failure at its starting point, at its origin. So the point at which damage occurs, you should be able to identify that straight away.
So is this something that can only be applied to new machines, or is it something that can be retrofitted to older machines that don't have this technology and you don't have the historical data of them?
That's a fair question. Absolutely, you could, in theory, apply this to any machine at all. If you are chasing reliability and you're looking at predictive maintenance as a way of doing that, you would have to address the reliability first. So that's a very important point, because if you have an old machine that breaks down all the time, simply putting sensors on it isn't going to make it break down any less. You've got to fix your maintenance practices, you've got to fix your lubricant storage, you've got to train your users, your operators, your maintenance personnel. So sensors aren't the complete solution, but they are a technology that's new and innovative. And with regards to condition monitoring, it has completely changed the way it's done. It's changed what is possible to do. So one of the things that really clearly differentiates the Industry 4 predictive maintenance from the Industry 3, for want of a better term, condition monitoring, is the accuracy at which the information is going to give you some answers.
So you've spoken briefly about training people and placing sensors onto machines. This obviously would have a cost associated with it. Would condition monitoring have a greater benefit than doing preventative maintenance, in your view?
In my view, the answer is always going to be, well, yes, if it works. There's always a possibility of anything that you apply not working. One of the questions that will be asked, of course, by anyone who's considering this is there going to be a return on investment? Is it worthwhile me doing all this work and retraining people and putting sensors on machines and getting cloud data? Is that going to pay for itself? The answer isn't necessarily clear. It absolutely could pay for itself if it's done correctly, but you actually need buy-in from everyone within the business. One of the problems that has occurred in the past with condition monitoring is that you can make some decisions on what you're going to do with the machine, when you're going to intercede and do some work, and plan for that work. But then the production department will say to you, no, I'm sorry, we need that machine. We have to keep production up and we can't give you that machine and you can't do that work. So if that's the case, then everything that you've done has been lost. But if the maintenance department has the ability to make plans and can do something about it, then the fact that they're collecting that data means that data is going to work for them and there will be a return on investment.
So the machine becomes more reliable and there are processes in place to ensure that happens. Why would we need to consider condition monitoring on that machine?
Yeah, so if you look at it in theory, then I'm saying you need to address reliability first and then you put your sensors on. It's not quite that simple. What the idea is that once you have a reliable machine, having the sensors on there and collecting that data gives you the ability to predict how that machine is going to go down in the future path, because all machines are going to need intervention, all machines are going to need repairs. So these sensors are going to give you the ability to collect the data and more accurately make your predictions. And it makes you better at what you do. So ultimately, the way I describe this often when I'm doing the training is that we really have to think about what maintenance is about in the first place. If you look in the Australian context, in the Australian industry, maintenance people fix machines and they do repairs. Now, one thing that is fundamental to me is that the maintenance department are there to maintain the machines. The maintenance department, more broadly, are not there to repair the machines. Otherwise, it wouldn't be called the maintenance department. It would be called the repairs department. It's all about having the knowledge, having the skills, and having the technology to be able to be reliable. That's what our industry demands, and that's what Industry 4 is able to enhance.
Thank you, Paul. Thanks for coming into the studio today.
My pleasure.
Thank you, everyone, for tuning in. And I'm going to make a prediction on the theme of this, that we're going to have part 3 of digital transformation, so stay tuned. Thanks for joining us on this episode of HYDAC Podcast. For an in-depth learning on the subject you've just listened to, enrol on the technical training at HYDAC Australia. For more information, visit our website, hydac.com.au. HYDAC, global presence, local competence.